Okay, example 2, it says a curve has the equation y equals 8 over the square root of x. Find the coordinates of the point on the curve where the general gradient dy by dx is equal to minus 32. So, minus 32 is the actual gradient at some point in this curve. We have got to find the coordinates of that point. So the strategy is you differentiate the curve to get the general gradient. You then set the general gradient equal to the actual gradient, and you solve that to get the x coordinate of the point. So let's do that to begin with. So we have our curve y equals 8 over the square root of x. Now, unfortunately, we're not ready to differentiate because we've got roots in it and we've got x in the bottom line. So let's deal with the root first. So that's 8 over x to the power of a half. Now we're going to deal with x. We're going to move x to the top line. And remember, it's only ever x that you move to the top line if it's on the bottom line. And then you change the sign of its power. So that's going to give us 8x to the power of minus a half. So that's our curve. We're now ready to differentiate in order to get the general gradient. And our general gradient is always known as dy by dx. So differentiate the curve then. So we're going to multiply this term by the power of x. So 8 multiplied by minus a half, well, it's going to be a negative. And then 8 multiplied by a half is just going to be 8 over 2. And then we're going to copy down x. And then we're going to subtract 1 from the power. So that's going to give us minus 3 over 2. In other words, minus 1.5. Okay, let's tidy it up. So I'm going to cancel the fraction, and I'm also going to move x back to the bottom line. So we've got a negative. 8 divided by 2 is just going to give us 4. And then I'm going to move x back to the bottom line. So that's going to give us x to the power of 3 over 2. Okay. Now, I could go a bit further and I could put the roots back in, but I'm happy to leave it like that for now. So we've worked out the general gradient at any point on the curve. Now, we want to get the coordinates of the point where the actual gradient is minus 32. So in order to get the x coordinate of this unknown point, we're going to set the general gradient, dy by dx, equal to the actual gradient. And the actual gradient here is minus 32. So the general gradient, dy by dx, is minus 4 over x to the power 3 over 2. And that's equal to minus 32. Okay, now plan. We could cross multiply, or I'm just going to multiply through by x to the power 3 over 2 in order to get rid of the denominator here. So multiply through by x to the power 3 over 2. So we're going to end up with minus 4 is equal to minus 32x to the power of 3 over 2. Now, we're going to get x by itself, so I'm going to divide both sides by minus 32. So we're going to have minus divided by minus is going to give us a plus, and then 4 over 32 is going to give us 1/8. And that's equal to x to the power 3 over 2. Now, we're now trying to solve an equation where there's only one term on each side of the equal sign, and we've got an indice here with an unknown base. Now, when the base is unknown, you want to make the power 1. Now we did this away back in September. To make the power 1, you take the reciprocal power of the other side. So what we do is we put brackets around the other side and we apply the reciprocal power to it. So the reciprocal power of 3 over 2 is going to be 2/3. And once you apply the reciprocal power to the other side, then you've got rid of the 3 over 2 here. So you're just left with x. So we're taking the reciprocal power of 1/8. Okay. So let's work out 1/8 to the power of 2/3. You could type it into your calculator, or if you remember, the denominator tells you what root to take. So we're taking the cube root of 1/8, and then the other power is just going to be 2, and that's going to give us just x. So the cube root of 1/8 is going to be 1/2, because 1/2 by 1/2 by 1/2 will give us 1/8. So that's just 1/2. You could also use surge rules and take the cube root of 1 and the cube root of 8. Again, you'll get the same result. And then that's all to the power of 2. And then we're just going to multiply 1/2 by itself. So we're going to get x is just 1/4. So after all that work, we've just worked out the x coordinate of the point on the curve where the actual gradient is -32. Now we've now got to get the y coordinate of the point. So in order to do that, we sub the x coordinate of the point into the curve because the point lies in the curve. So go back to the curve right at the beginning, y equals 8 over the square root of x, and we're going to sub in 1/4 for x. So when x equals 1/4, we're going to get y equals 8 over the square root of 1/4. Now, this square root there's only a positive before it, there's no negative here, so this is only the positive square root. So you take the positive square root of 1/4, you're just going to get 1/2. So that's going to give us 8 over 1/2. And then 8 divided by 1/2 is the same as 8 multiplied by 2, so that's going to give you 16. So there's the y coordinate of the point. So the final answer, so the point is 1/4, 16. And that's it. So that is how you find the coordinates of a point on a curve when you're given the actual gradient at that point. So in summary, you have to differentiate the curve to get the general gradient at any point. You then set the general gradient, dy by dx, equal to the actual gradient, and you solve that equation to get the x coordinate of the point. Finally, you sub the x coordinate of the point into the curve and you'll get the y coordinate of that point. And then you're just writing down your answer.